is false. B is 0. 0 is greater than E, and E is 2 is also false. We have false or false, and the end, the result is false, which means we have to go back to the beginning and do the whole thing again, starting from on line 4. Line 4, once again, is calculating the sum of B and E. B is 0, E is 2, so the sum is 2. 2 divided by 2 is 1, and the floor of 1 is just 1. M is, in this case, will become 1. Are we doing okay so far? Okay. And then we move on to line 5. Line 5 is asking the same question. A bracket M is less than K. This time, is it true or is it false? We're comparing A bracket 1, which has a value of 3, to K, which has a value of 5. 3 is less than 5 is true. We execute line 6. Line 6 will update B. It will update B as M plus 1. M has a value of 1 at this point. 1 plus 1 is 2. Are we okay? So at this point, B and E are exactly the same, which means we have one element that can potentially still have the value that we are looking for. After line 6, we get out of the conditional statement. We go to line 10 to see if it is time for us to go. And the answer is no, because we have not found the element we are looking for. B that is not greater than E either. So in this case, the entire disjunction is false. We have to go back to line 4 one last time. 2 plus 2 is 4.
B is 2 and E is 2.
Yeah, but 2 is greater than 2 is false. Yep. So we go back to line 4 again. 2 plus 2 is 4. 4 divided by 2 is 2. The floor of 2 is 2. So finally, M itself is also 2. We go to line 5. We compare A bracket M to K. A bracket M refers to A bracket 2, which has a value of 6. 6 is less than 5 is false. We move on to line 7. We check whether K is less than A bracket M. The answer is true. Because K, okay, let me do this a little bit. Because K has a value of 5, and A bracket 2 has a value of 6. 5 is less than 6 is true. This means we have to go to line 8. Line 8 is going to update E with M minus 1. M has a value of 2. 2 minus 1 is 1. So eventually E is now less than B. We get out of the conditional statement. We go to line 10. The first condition or the first comparison is still going to return false because we have not found an element with the value that we are looking for. But the second comparison will become true. One of the conditions is true. That means the entire disjunction is true. And then we get out of the loop. Okay. Mm-hmm. Are there any questions about this trace? Yep. Go ahead.
Line 11 should be put the value in found of S.
Oh, that's right. I forgot about line 11. Okay. On line 11, we evaluate the assignment statement. In this case, we have A bracket M equals to K on the right-hand side. A bracket M equals K returns false. Okay. It returns a value of false. We just store that into the variable found. That means found here will have a value of false. And then we are done. Thank you. I forgot about that. Okay. Now, can you guys see, how the values of B and E, they kind of, get closer and closer? If you're looking for something that is not in the array, at some point, B and E will be exactly the same. And because none of the elements in the array is what you're looking for, either line 6 or line 8 will execute, depending on the result of the comparison. But either way, it will either move B one step earlier than E, or it will move E one step after B. But either way, they will they will cross over, and then the condition on line 10, B is greater than E, will become true. Any questions about this? Yep.
Why aren't we updating the elements?
We are not updating the elements. The elements never got updated. we're searching. This is a binary search algorithm. We are only trying to determine whether a value is in an array or not. Right. This is a search algorithm. It is not, an algorithm that will change the values of the array. Okay. Any other questions about binary search? Now, since we are here, you guys can do some exercise when you go home. You can get rid of the +1 here and get rid of the -1 here, and then just repeat the same test cases that we have gone through in the class and see what happens. You can see whether you can still find the element that you want to find, when you're looking for a value that is in the array, and you can see what happens when you're looking for a value that is not in the array. Will the loop terminate? And the answer is, it's not going to terminate. But you should see for yourselves, how it is not terminating. Because at some point, B and E will become exactly the same. And when they become the same, B plus E divided by 2, and the whole thing, you take the floor of that will not change either. And that's why it will never terminate, because it does not change. Are you guys kind of seeing what I'm saying? Okay, let me just write it on the whiteboard here. Okay, at some point, let's say B becomes the same as E, okay, because those two are getting closer and closer together. Also, let's say that we made a mistake. So on line 6, we don't have the +1. On line 8, we don't have the -1. The way we calculate M is it is the floor of B plus E, the whole thing divided by 2. But when B equals E, then M will eventually become the same as B, which is the same as E, right? Now, if that is true, we will get to either line 6 or line 8, depending on the comparison. But because we don't have the +1 anymore on line 6, we don't have the -1 on line 8 anymore, we are just copying B or E over we're copying M over B and E again, but they already have that value to begin with. At some point, this means that it will enter an infinite loop because B and E are no longer getting changed, after that point. But you should try it out for yourselves, and just to see, when it does happen. Okay. Any other questions about loops and binary search, arrays, stuff like that? No questions? Okay. Let's go back into subroutines. Oh, wait, I need to save this file into today's folder, so this way we won't lose it. Because right now it is saved into a temp folder when I unzip it. So I will save it into today's folder. And I will save it under the same name, binary search. I will have to re-upload the file, later on, because the zip file that is already on Moodle does not contain this file. Let's go back to the browser. Where is it? Here. Let's go ahead and continue the discussion of subroutines. Of course, I cannot remember what we talked about last time. It was just Monday, too. Okay, we looked at recursion. That's good. It's going to be here at some point. It has to do with using a flash media. It is slow to access. If I use an external hard drive, it would be much faster. Okay, and this is what we looked at last time. We have an algorithm or a subroutine called mysterious. This is the fixed version. This one will terminate. And the whole point of this is to indicate that there's nothing mysterious about calling a subroutine or invoking a subroutine from itself. The bottom line is you have to just follow the mechanisms as we have dealt with the same thing in other places. If you follow the same mechanisms correctly, this is nothing mysterious at all. So to the contrary of the name of this subroutine, it is actually not mysterious. Are there any questions about subroutines? Yep, go ahead.
I just have a once you do the if, do you go back to see if that?
No, we do not. Remember the picture. Okay. The question that you're asking can be answered, best by a picture of a conditional statement. A conditional statement, if you look at the trail map, it looks like this. Okay, you have two branches, or potentially two branches. One side can be empty. This side can be empty if I don't specify an else. But eventually they will merge again. Now the important part is to remember these are all one-way streets. Okay, so we have one-way streets all over this entire map. This is an operation you can perform. This is an alternative operation that you can perform. Which way you choose to go depends on the answer to a question that you have to answer in order to determine which way to go. If you look at this graph here, there's no way you can go back to this point to reevaluate this condition. In other words, a conditional statement is a one-shot deal. Okay, you start from the beginning, you go through, you make a decision to go one branch or the other branch, you perform the operation of that branch, and then you get out of the conditional statement. You cannot go back to the beginning. Now, this is not saying that we cannot do it. You need to rely on a loop outside to give you the ability to go back.
And the loop would be if this is while, whatever?
Yeah, if you have a conditional statement inside a while loop, then you can go back to the beginning. But it is not because of the conditional statement that you're going back to the beginning. It is because of the loop that is outside of the conditional statement that you can go back to the beginning.
Gotcha. Okay, thank you.
Sure. Yep. Okay. Any other questions about conditional statements? No? Okay.
Going by that picture, when we access a subroutine, it's like telling somebody to take a different route on the trail, right? Saying just go up that mountain on like a detour.
A subroutine is like, okay, let's say someone is walking down this hallway. Okay, that's the flow of the program. Okay, walking down the hallway. A subroutine is like, oh, well, let me take a look in this room. You get into the room, you do whatever you need to do inside the room. When you're done, you get back out onto the hallway, and then you continue, where you were going before. So that's one way to look at subroutines, is you're on a path, and then, at certain points you want to invoke a subroutine, which is the same as going into a particular room to perform whatever operation that room specifies. But when you're done with that operation, you get out of the room and you continue on the path that you were originally on and continue the execution. Now that analogy doesn't really lend itself to calling a subroutine inside a subroutine because that means inside the room you have another room that you can visit. So the analogy only goes so far. I can only push it so far with that analogy. Okay, any other questions about subroutines so far? No other questions? Well, I have one question. If you look at this variable x here, can I do something like this? Okay, I'm not going to save this file because there's no point in saving it at this point. After all the calculations by Mysterious, which is nothing more than adding x until it becomes 3, if I do a print x here, what is this statement going to print on line 9? Whatever x is at that point, which is going to be 3, right? Now the next question is, so x is a variable that is accessible from outside of the subroutine as well as from inside of a subroutine, right? And that's why x in this case is called a